projectile refers to an object that is in flight after being thrown or projected. In a projectile motion, the only acceleration acting is in the vertical direction, which is acceleration due to gravity. Equations of motion, therefore, can be applied separately in x-axis and y-axis to find the unknown parameters.
Some examples of projectile motion are football, a baseball, a cricket ball, or any other objects. The projectile motion consists of two parts. One is the horizontal motion of no acceleration, and the other vertical motion of constant acceleration due to gravity. The projectile motion is always in the form of a parabola, which represents as y equals ax plus bx squared. Projectile motion is calculated by a way of neglecting air resistance in order to simplify the calculation. Jimmy had a big baseball game last weekend. He hits the ball from 3 feet off of the ground with an initial velocity of 150 feet per second and a launch angle of 45 degrees. Jimmy wants to know how far the ball traveled. First, we have to find the variables. Here's what we know from the problem. VO being the initial velocity of 150 feet per second, theta equaling 45 degrees, and H0 equaling 3.
This is the ball, and this is where the ball ends up. X is the distance that the ball traveled. To find that, we use our formula, which is X equals VO cosine theta t.
When you plug in our equation to the formula, you get y equals negative 16 squared plus VO sine theta t plus HO. Because we're trying to solve how far the ball traveled, you do 0 equals negative 16 t squared plus 150 sine 45 degrees t plus 3. Then you do 0 equals negative 16 t squared plus 106.1 t plus 3. Then we plug it into the quadratic formula and get 2 times. One is 6.7 and the other is negative 0.03. But because we're dealing with time, this negative doesn't matter, so it gets crossed out. Now that we solve for that, it equals 150 cosine 45 degrees times 6.7. Then we see that x equals 710.6 feet, which is insanely far.